Fixed versus fluid website layouts. In previous chapters, we discussed attempting to have our website work on most, if not all, browsers. Now we're going to discuss attempting to have our website work on most devices, or to be more specific, on the screens of those devices. And we're going to talk about the challenges related to that. Nowadays, we have so many different devices connected to the internet. They all have screens that display web applications, websites, and so forth. Some examples are the 15-inch laptops, the 27-inch desktops, the iPads, the 9.7-inch iPads, the internet wristwatches, the Blackberries, the iPhones, and so forth. When we talk about screen sizes, we're talking about the diagonal that goes from the upper left or right to the lower left or right. And that's how we measure screens. So with every new machine or device that's been created, there has been this challenge of having web pages work on small and large monitors. By work, we mean for them to show properly on the screen. So we're basically referring to the layout. There are two ways to prepare a layout: fixed and fluid. A fluid layout is a website layout that expands or compresses with a browser's window's width. A fixed layout is one where a website size does not change as the browser window's width increases or decreases. Let's look at some examples. Here's a fluid layout in a 1024 by 768 pixel screen resolution. And here's the same fluid layout in a 1280 by 1024 screen resolution. When I say screen resolution, I'm basically talking about the number of pixels across and the number of pixels down. So I go to my screen resolution by going to System Preferences and then Displays. And the best resolution that I can get on this device is 1440 by 900, which means I have 1440 pixels from left to right and 900 pixels from top to bottom. So this is an example of a fluid layout that expands or compresses. And in this example, it obviously compresses with the small screen of a Blackberry, in this case a 320 by 240 pixel screen resolution. As opposed to the fixed layout, so we have the same website, but this time it's a fixed layout in a 1024 by 768 screen resolution. And the same website is then opened in a 1280 by 1024 screen resolution. Let's explain what's happening here. The first picture on the left means that the fixed width of the web page is around 924 pixels, which leaves a margin of 50 pixels on the left and the right. So 50 pixels on the left, 50 pixels on the right. If the screen resolution obviously is 1024 pixels from left to right, then the container is 924 pixels. Now the second image on the right is basically saying that the fixed width of a web page is still 924 pixels, but since the screen resolution is 1280 in width, it leaves a margin of 178 pixels on the left and on the right. Okay, so that's the difference between a fixed layout and a fluid layout. The fixed layout does not expand or compress with the screen resolution. And similarly, on a very small screen, we would end up having scroll bars on the right and the bottom because the website is fixed, and so it's not scalable. It won't compress to fit the small screen of the Blackberry. Advantages and disadvantages of both. One of the advantages of a fluid website is the ability to see more content. It is ideal for people carrying small resolution monitors like mobile devices, and usually we don't have to scroll sideways. One of the disadvantages is that the website might look minute on small resolution monitors, and we could have long line lengths. A line length is basically a horizontal length of line on the screen. If we're a good designer, we avoid very long line lengths. The longer the line is, the harder it is for a user to find the beginning of a line of text after reaching the end of a line before it. One of the advantages of a fixed website is that we know exactly how our website will look for all people. And we prevent long line lengths, especially for large monitors, which will comfort our readers. The disadvantages is that we'll have a scroll bar on small resolution monitors. To make a fluid website, we need to consider three things: fonts, layout, and images. We use the percentage or the EM unit of measurement in CSS instead of pixels when dealing with fonts. We use the percentage and not the pixel normally on the width when working on a layout. And we use the percentage and not the pixel on either the width or the height for images. To make a fixed website, we consider three things. Again, fonts, layout, and images. For the fonts, we use the pixel unit of measurement in CSS. For the layout, we use the pixel on the width and sometimes the height. For the images, we use the pixel on the width and the height. The fonts. Let's define each of the units. The EM, one EM is equal to the default text size in a browser, 16 pixels, assuming that 16 pixels is the default in a browser. Usually it is. If we go to Firefox, if I go to Firefox Preferences, and under Content, I find my default font happens to be Arial, and the default size happens to be 16 that I can change. The value that I change it to here becomes the default. So if I build a website and don't specify the font size, my website is going to inherit whatever default size there is here, unless I specify that I want a certain paragraph or word to be a specific size. So 1 EM is equal to the default text size in a browser, which is usually 16 pixels. Since scalable in nature, 1.5 EM is 24 pixels, increasingly popular in web documents due to scalability and mobile device-friendly nature. The percentage, 100%, is equal to the default text size in a browser, which is 16 pixels, which means 100% is equal to 1 EM. Since scalable in nature, 150% is 24 pixels. The text remains fully scalable for mobile devices. 1 pixel is equal to 1 dot on the computer screen, the smallest division of a screen's resolution. Since fixed-sized units, pixels are used in screen media, that is to be read on the computer screen, and popular among web designers in producing pixel-perfect websites. The pixel unit is not scalable, so unfit for mobile devices. 1 point is equal to 1/72 of an inch. Points are traditionally used in print media, and like pixels, they are fixed-sized units and cannot scale in size. So if we look at conversions based on a 16-pixel browser default size, 16 pixels is equal to 1 EM, which is equal to 100%, which is equal to 12 points. Obviously, again, based on a 16-pixel browser. Layout. Let's look at fluid websites and fixed websites. The first example on the left is a fluid website. So if we have div ID container, assuming that div ID container is the main div on a web page, and when we say in CSS width 70%, we're basically saying 70% of the whole screen. So we want the div container to be 70% the width of the screen. So if my screen resolution is 1440 pixels, then I'm saying 70% of 1440. As opposed to the fixed website, we would say width 800 pixels and not 70% or some value in percentage. In nested divs, In this example, we have a small div nested in a bigger div. And if we are basically giving the big div a fixed size, for example, width 900 pixels, and then we go ahead and give the small div a 70%, what does that mean? It means 70% of the parent div, which means 70% of the 900 pixels. So this example at the bottom is not a fluid example, it's a fixed example. We just happen to be using the percentage value, but as long as the parent has a fixed value, which is in pixels, then it's a fixed layout. Images. For fixed website layouts, we use the pixel on the width and the height. For fluid website layouts, we use the percentage and not the pixel on either the width or the height, because applying the percentage on both the width and the height will cause distortion on certain browsers. We need to leave one dimension loose so that it scales proportionally. Screen resolutions. When we talk about measuring or describing screens, we are basically referring to two things. How big they are, the physical dimension of a screen that we get by measuring the size of the diagonal. We saw this earlier. And what resolution they have, or the number of pixels across and the number of pixels down. The way resolution is represented is by an invisible grid. At the center of each square of that grid is a circle. The closer the circles are together, or the shorter the distance, the higher the resolution. The further apart, or the greater the distance, the lower the resolution. And this is the invisible grid, with each dot or circle being a pixel. Let's look at this example. Consider an image of 500 pixels in width and 375 pixels in height, open on the same laptop, once with a screen resolution of 1024 by 768 pixels, and once with a screen resolution of 640 by 480. When the image is open on the screen resolution of 1024 by 768 pixels on the same 12-inch by 9-inch laptop, it appears as such. And when the same image is open on the same laptop but with a different screen resolution of 640 by 480, it appears bigger, but it loses resolution. Even though the image on the right occupies almost most of the screen, it has a low resolution because the distance between each 2 pixels of the 640 in width and 480 in height is big. The image on the left occupies part of the screen only, and it is of high resolution because the distances between the pixels is small. And so screen resolution is the inverse of the distance between two adjacent pixels. The greater the distance, the smaller the resolution, and the smaller the distance, the greater the resolution.